This is the solution to the second example for calorimetry. We have 50 milliliters of 0.300 mole per liter copper 2 sulfate solution. We mix it with an equal volume, so again 50 milliliters of 0.6 mole per liter sodium hydroxide. These two aqueous solutions produce a precipitate of copper 2 hydroxide and aqueous sodium sulfate. The initial temperature of both solutions is 21.4 degrees Celsius. After mixing, the highest temperature is 24.6 degrees Celsius. Determine the molar enthalpy change for copper sulfate. So we want the molar enthalpy change for copper sulfate. So this has identified the system for us. System is going to be the copper sulfate solution. So when we calculate delta H is equal to N delta HX, this N will be moles of copper 2 sulfate. So we have solutions here, two of them, and we mix them together. When we mix them together, the final total volume will be 100 milliliters. These volumes we add together to give us the mass of our calorimeter. This is the only time you're going to add the mass of the system and the surroundings, when you have two solutions. It's the only time. So for Q equals MC delta T, this is for the surroundings. We're going to include both volumes. So we've got 100 milliliters. But 100 milliliters is not in grams. So you have to convert it. Remember, one of the assumptions of our calorimeter is that all dilute solutions have the same density and specific heat capacity as water. So you have to show this step. You convert milliliters to grams. So now we can plug this value into here. So Q is equal to 100 grams of solution times specific heat capacity of water times your temperature change. So 24.6 minus 21.4. So your temperature difference is 3.2, and it went up. So the heat content of our surroundings went up. So this is in fact going to be an exothermic system. So 4.19. So now we're going to figure out what our Q value is. So Q is equal to 1340.8 joules. And we know that delta H is equal to negative Q. So delta H is negative 1340.8. We said this was going to be an exothermic system because the temperature of the surroundings increased. And here we go. There's your negative. So it's exothermic. So delta H is equal to N delta HX. So we need to solve for moles of copper 2 sulfate. Concentration is moles divided by volume. So moles would be concentration times volume. The concentration was 0.3, and we had 50 milliliters. So you have 0.05 liters. So altogether we have 0.015 moles of copper 2 sulfate. So now we're going to plug that value and our delta HR into our formula to solve for delta HX. So divide both sides by 0.015. And the value is 89,386.67 joules per mole. So because this is in the thousands, we're going to make the joules go to kilojoules. So if we divide this number by 1,000, we have 89.4 kilojoules per mole. There's your molar enthalpy. So if you're adding a solid to a solution, you do not add the masses for the calorimeter, but when you mix two solutions together, you add the masses for the mass of the calorimeter, because you're taking the temperature at the end of both solutions at the same time.